Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is Planet 9. And with me here in the studio to discuss this is our own Stephen Whitty. Hi there, Stephen.
Hi.
Now, Planet 9, this sounds familiar. What Planet 9 are we talking about?
Yeah, so a couple of the Planet 9s that we're not talking about. We're not talking about Plan 9 from Outer Space, a 1959 Ed Wood film. It apparently had vampires and had some space theme. I don't think I've seen it.
I don't think so either, no. So what other Planet 9s aren't we talking about?
Yeah, so we're also not talking about Pluto, which was originally the ninth planet. So in 2006, the International Astronomical Union demoted it from planethood. Poor Pluto.
Yeah.
But no matter what you think of Pluto, Pluto is a real dog. That is R-E-E-L.
Oh.
It's pretty bad, yeah.
Yes, it was.
Yeah. So what we are talking about is Planet 9, which is an undiscovered planet, and I thought it would be fun to go through. It's fun to speculate always, but I thought it would be fun to go through what evidence there is of it. It hasn't been discovered. We haven't got a picture, but.
But if it hasn't been discovered, then what is there to talk about? That's like talking about something you haven't found yet.
Yeah.
But.
So we do have some evidence. And it's kind of interesting. There are actually 5 lines of evidence, but we'll get to that a bit later. The thing that actually started this was the discovery of Sedna, which is a body in the
it's a Kuiper belt object.
It's a Kuiper belt object, but it has a few very peculiar. This is actually a picture. That was actually a picture of Sedna. I did the math. It has to be like 1/3 of a pixel in the Hubble Space Telescope. So that was the best picture that we've got. It's really, you're looking at a dot. There's really not much
There's nothing wrong with your television set?
Yeah, it's a fuzzy dot there in the middle of the picture of the thing. So Sedna has this weird orbit. The closest it gets to the sun is almost 3 times the distance that Neptune is from the sun. So it's way out there. And when it's that far out, Neptune doesn't get to perturb it any. So how did it get a closest approach to the sun that's so far out? Nobody knows. Well, when you just have Sedna to look at, there isn't that much to it. It's also got a big elongated orbit, highly elliptical orbit. So the sun in this image is way off to the right, and you can see the biggest ring is the orbit of Neptune with Pluto also, and so it's a big elliptical orbit, and it was found at its closest part, closest approach to the sun, and that's because if it wasn't currently at its closest approach to the sun, we simply wouldn't see it. We don't have telescopes that can see a 600-mile across object
at that distance.
At the farther distances. Yeah.
Sure.
Yeah. So,
galaxies, yes. Minor planets, not so much.
Right. So this was the first of several objects that was discovered, and
so that's some of the evidence.
That's some of the evidence.
Okay.
So then the next, now we've got an image with orbits of a bunch of objects, and all of the ones that head off to the left, especially there's a group of them kind of in the upper left here. You can kind of see that they're going more or less in the same direction. They've got this elongated orbit, and it's all going more or less in the same direction. Sedna is actually in the lower left. You can see its orbit. And all of these objects were discovered when they were closest to the sun. So what we're getting at is something that could explain why all of not all, but almost all of the objects that we're finding have orbits that are elongated in the same direction.
Because I see you've got Planet 9 in this drawing is on the opposite side.
That's right.
So they're thinking that it's a Planet 9 that's perturbing these orbits.
Right. So So Sedna isn't Planet 9, and neither are all of these other things. And the Planet 9 orbit here is the proposal. So Mike Brown was on the team that discovered Sedna. So you could say, well, and Sedna and a bunch of others were sort of candidates for why Pluto was demoted. Really, Eris was the key. Eris is essentially the same size as Pluto, a little further out, but still closer to Neptune, and Neptune is still
exactly
controls it. But Sedna isn't controlled by Neptune, so it's a real puzzle. Like, how did it get there, and why is it still there? And then since then, we've found those others.
So if Sedna isn't Planet 9, then how does it fit in? I mean,
so you need something that will explain the detached orbit. It's not an orbit controlled by Neptune, so how did it get there, and how does it stay there? And so one hypothesis is you've got a more substantial planet, and Planet 9 is one of these things. So Mike Brown and Trulio and who was the other guy who discovered it? Here we go, Shepard. These guys said, well, maybe there's something out there, and there were some other sorts of ideas. Now, Mike Brown is an astronomer who actually looks through a telescope, or it's all CCDs these days. So it's all
sure.
a camera, and you look at the images, you look at the data. But what he needed in order to for a Planet 9-like discovery, Trulio had written a paper in 2014 talking about, well, there could be another planet out there, and what are some of the characteristics it might be. So it got the ball rolling. But Mike Brown went down the hall at Caltech and to Konstantin Batygin, who is a planetary dynamicist. Just down the hall, right? So
how convenient.
That's
yes.
right. So they collaborated, and a lot of this story is about Konstantin Batygin, who, by the way, gave an excellent 1-hour YouTube video. You can find it. So in 2016 or 2017, I guess he put this up. But he started out by doing some pen and paper math.
Definitely old school.
And I'm not going to go through the math, so here it is. But here's some of it from Batygin and Brown's 2016 article that you can find on Arvix. So I actually have gone through some of this and tried to figure out what they're talking about, and it actually does kind of make sense. But I'm not actually familiar with quite everything here.
But this is part of their explanation as to why all of those Kuiper Belt objects we saw earlier, their orbits stay perturbed.
No, actually what he's trying to do here in the math is he's trying to get an idea what the orbit of Planet 9 would be, and using the pen and paper, he was able to inform how to set things up for a computer simulation. And they did a number of computer simulations where they would start out with, say, 100 or 500 particles. The mass of these objects, even Sedna is, it's smaller than Pluto's moon Charon. So it's not huge. So they call it particles, right? So they don't really care about the mass of these things. And then they do a simulation over the lifespan of the solar system, and they came up with some interesting features. So that
they could plug in to make this.
Yeah, right. So you're trying to explain, the closest approach of Sedna and these other objects, and you're trying to explain other things, and and the grouping of the orbits and stuff. And they came up with some interesting ideas.
Yeah, very interesting indeed. We're going to take a quick break right here to have a look at Term of the Month. It'll be coming up in just a few minutes. Now, if you have a question, please, as always, send us an email. You can see that address right down there at the bottom of your screen. And right after the aforementioned term of the month, we'll be back with more discussion on Planet 9.
The term of the month for February 2018 is the Southeast Michigan meteor of the 16th of January 2018. So this is hot off the press. There were hundreds of reports of a meteor. It was a bolide that exploded, so there was it was a brilliant flash of light. It got caught by dash cams, just like in Russia, and it also got caught on security cameras and so on. So weather radar saw what looked like rain, and our intrepid crew went out to the site where the fall it was thought to happen, and there happened to be a lake that was covered with snow. Anyway, our intrepid crew with Todd Slisher, Tony Licata, Brian Wolf, Buddy Stark, and Sandra Masica went out to find meteors, and they found some. So this is for scale. They're like an inch across, maybe a little bit smaller, and there were, of course, 3 meteors. So we've got a rocky, stony sort of thing that found. So this is this rock bounced off of the ice, and it made a little hole in the snow, and it bounced off. So this is a discovery image. It's awesome. And then this one got buried a little bit. It's really kind of interesting. And then finally, this one just sort of is sitting there right on the snow. In this picture, you can kind of see in the plastic bag, it looks silvery. That's because it's wrapped in tinfoil to protect it for both of these. And that is the term of the month for February 2018, the Southeast Michigan meteor.
Welcome back. In the first part of the program, we've been talking about Planet 9, and to continue the program, we'll be right here with Stephen Whitty. Now, Stephen, you mentioned a few names in the first part. Who's working on this program besides the fellows we talked about?
Yeah, so Mike Brown and Konstantin Badigan, they published a paper in January of 2016, and I just did a look through the references, and it turns out that there are 46 astronomers who are named in the paper, and of those, 16 are so-and-so et al., meaning they're part of a team. So there's 16 teams of astronomers who are working on this. But in addition to that, so the paper actually mentions people as far back as 1950 having written stuff about the planetary dynamics, the orbital dynamics. But Konstantin Badigan, in his early 2017 video on YouTube, he also mentions Kepler. This is 1600, and he also mentions math when doing all of the simulations. He says it's all Newtonian math. So he doesn't. I don't know that he says Newton by name, but he actually refers to him by his equations. Really.
Oh, okay.
Right. It's all inverse square law. Math.
So with all these groups that you're talking about, the search is still ongoing?
The search is ongoing. So you have the astronomers who are studying the data, but there's a survey that started in 2001 that found Sedna, and it continues. But in addition to those searches, there was the WISE satellite. It was an infrared satellite in Earth orbit that did an infrared survey of the entire sky, absolutely the entire sky. So they looked through all of the data. The mission is over, so they looked through all of the data to see if Planet 9 might be there. And that data does place constraints on where Planet 9 could be in its orbit. It has to not be very close to us. There are other surveys, ground-based surveys, that also point to it can't be in the nearest part of the orbit. So, in this image, Planet 9 has to be way out toward apogee, farthest from the sun, aphelion, farthest from the sun. There you go. It can't be off to the left, closest to the sun, perihelion. He's showing it, I think, arbitrarily. I don't think that's his best guess where it is in the orbit. I think it's actually farther, but he does actually have a best guess, and they've gotten some time on the Subaru telescope, which is an 8.4 meter telescope in Hawaii, and now the field of view on that, it's one of the better fields of view. It's a bigger field of view for the large scopes, but even that isn't, absolutely huge. So it could take weeks or months to find it. One of the estimates is that even at aphelion, Planet 9 should appear to move over the course of, from one day to the next. Now, most of that movement isn't Planet 9 moving in its orbit because it's moving very slowly out there. Mostly what you get, most of the effect should be parallax.
Okay.
So, and that's
would that be from the Earth moving?
And that's from the Earth moving for a day.
Okay.
Right, for just a day, right? So, eventually we could get parallax, where the Earth is on one side of the sun and then on the other side. But anyway, this one day thing, you basically have to be near opposition. So for a few months around opposition, because that wouldn't make much difference, to see a parallax change.
Now, we talked about Planet 9 affecting the orbits of Sedna and those other Kuiper Belt objects. Would a planet that big have other effects besides perturbing those orbits?
Oh, absolutely. So there are 5 solar system features that could possibly be due to Planet 9. And we'll just go through them. We'll go through a couple here. First is we have all of these objects, like on the screen, and they have these large perihelia. Closest approach to the sun is way outside of the orbit of Neptune. So what could be keeping them there? And a Planet 9 could certainly do that. The other thing that this Planet 9 could explain is why the elongation of the orbits all seem to be in more or less the same direction. And Planet 9 could also explain that. The simulations show this. Now, in the diagram, Planet 9's orbit is in the opposite direction of these other objects. And it turns out that only 10% of the objects that are simulated end up falling into one of these opposite orbits. But they also turn out to have the perihelia close enough for us to actually see them. We would see these objects before we would see objects that have even farther closest approaches to the sun. So the way that we have discovered them, we're at the beginning of this search.
Sure.
There should also be some objects that are captured in the same direction as Planet 9, but we are less likely to see them right away. So that's two things. It's basically how far out from the sun these objects are and what angle from, in some coordinate system, what angle or range of angles that they appear in.
Now, the survey that found Sedna, we talked about Sedna earlier, began in 2001. Is that still ongoing?
Sure. And so we've found some additional objects. And some of these additional objects turn out to have other weird properties, and these simulations actually show them. One of the things that the simulations showed is that the perihelia, the closest approach to the sun, for a lot of these objects, will get drawn into the solar system. And so are there objects that have perihelia that are, but they would still have these long elongated orbits.
Okay.
So are there objects that fit that bill? Are they closer? And it turns out that there are 6 objects that have perihelia that are farther out than Jupiter, but their semi-major axis, which is sort of the average distance from the Sun, those distances are over 250 AU. So they're way, way out there.
Oh my goodness! And an AU, of course, is the average distance to the Earth
from
to
the
the
Earth
Sun.
to the Sun. So 250 AU is on the order of 8 times farther out than Neptune.
Yeah.
So these things are potentially way out there. 6 of them that we know of them because these happen to be close to us. If they were out at 250 and above, then we wouldn't be seeing them probably. Maybe not. Anyway.
Doesn't sound like it.
And these objects have inclinations that are right, that seem to be right, and they. So here's another weird thing that Planet 9 should do. Some of these objects should have their inclination go way high. Not just 10 degrees or 18 degrees or something like that, but 90 degrees, absolutely going north-south on the Sun.
More perpendicular?
Perpendicular. So of these 6 objects that I was talking about, 3 of them are actually retrograde. They're past 90 degrees. There's 98 degrees, 147 degrees. So it's going backwards, right?
Oh my goodness!
And there isn't, you think, oh well, when you go from forward to backwards, there's going to be a problem. No, it's going over the Sun, so it never actually was any close to anything.
Wow.
The last thing is kind of spooky. We've known for over 100 years that the way that the Sun rotates is 6 degrees off from the plane of the orbits of the planets.
Okay.
And believe it or not, these simulations show that Planet 9's, it's got to be in an inclined orbit of its own. It actually changes the orbits of the big planets by about 6 degrees over the 4.5 billion years of the life of the solar system. So with all of these things that Planet 9 suggests, it would explain, these things could be explained in other ways individually, but having a single mechanism that explains them all is extremely exciting. So if Planet 9 actually is found, then we'll be able to tie up quite a bit about what we know.
Do we have an idea when we might be able to do that?
Well, the Large Synoptic Survey telescope, which is another 8-meter telescope, but it has this huge field of view. It's supposed to look at the entire sky from where it is in Chile. It's actually they've started building it. It should be able to see the entire sky every 3 days, and Planet 9 would. It's a very deep survey. It's a 25th magnitude survey. Planet 9 should show up.
Wow. We'll look forward to that.
Yeah,
that's for sure. So this has really been a fascinating discovery. I'm still thinking Planet 9's Pluto, but hey, that's just me. I want to thank Stephen for bringing us this interesting information on this topic. Check our website. We'll put that address down at the bottom of your screen. And once again, Stephen, thanks for being on the show to talk with us about this. And coming up next is What's Up in the Night Sky
with Don Glaser.
Thank you, Stephen. Thanks, Stephen. This is What's Up for February 2018. We'll begin with the Sun. On the 1st, the Sun rises at 7:46, but by the end of the month, on the 28th, it rises at 7:10. Sunset on the 1st, 5:47, and on the 28th at 6:20 p.m. Now, the difference on astronomical twilight from the time that it's dark enough to do astronomical observing until the sun brightens up the sky. Too much to see anything in the night sky with a telescope. At the beginning of the month, it's 1 hour and 36 minutes between the two, and by the end of the month, only 1 hour and 33 minutes, so basically the same. Now, in February, we do not have a full moon. It's referred to as a black moon because there isn't one in February. We actually have the second full moon of January occurring on the 31st, and the full moon occurs again on March 1st. Now, the last quarter, as you can see there, occurs on the 7th. The new moon, when it's between the Earth and the Sun, occurs on the 15th. And the first quarter moon appears on the 23rd. Let's switch now to the planets. Mercury is alone in the morning sky on the 1st, right around 7:30 in the morning. It's not very easy to see, partly because it's so low to the horizon and also because of the approaching dawn. Mercury is at superior conjunction, lining up with the Sun from our vantage point here on Earth on the 17th. Next, we have Mercury and Venus gracing the nighttime sky by the end of the month on the 28th. This is right around 6:30, 6:35. Venus will be fairly bright and shouldn't be too difficult to see, but Mercury, not so much. You might want to use a pair of binoculars to help search out Mercury in the glow of dusk, but please be very careful that the sun is out of the sky so you don't accidentally turn those binoculars towards the sun. Next, we have 3 planets in our morning sky. This is towards the end of February, looking towards the southeast, about an hour or so before the sun. Up at the top, we can see Jupiter. Next, down and to the left, just a little bit, is Mars. And just above the horizon, we can see the planet Saturn returning to our skies. Now, Mars is a red object. We can tell it that way because of the rust in its soil, but there's also another red-colored object in this scene. It's the star Antares. It's the brightest star in the constellation of Scorpius the Scorpion. So look for this configuration, again at the end of the month, looking southeast before sunrise. Now, lastly, we'll take a look at our solar system. And what this will help do is help us see this superior conjunction that I mentioned for Mercury just a few minutes ago. You can see the cutaway of the inner part of the solar system, and you can see how the Earth and the Sun and Mercury all line up together. And so hence, because Mercury is on the opposite side of the Sun from where we are, it is a superior conjunction, so we can't see it. If it happened when Mercury was between the Sun and the Earth, that would be an inferior conjunction. And that's our look at the nighttime sky for February 2018.